The topic that I'm going to talk about is a human-machine environment model for root cause analysis. And for those of you who may not know me, let me just introduce myself briefly. I actually got my degree in 1990 from State University of New York at Buffalo. Since then, I have been teaching in NTUST, National Taiwan University of Science and Technology. So it's been a long time. Nobody ever celebrated their anniversary for their teaching career, but then I got a notice from LinkedIn that this February I'm going to celebrate 35th anniversary, so it's been a long time. Thank you. There are some milestones that I was the president of the Ergonomic Society of Taiwan between 2003 and 2005. Last year, I got the fellow from the International Ergonomic Association. What I'd like to do for today, this will be my agenda. In the end, I'm going to talk about the classification scheme for helicopter accident. But before that, I'm going to talk about the man-machine environmental system and then the categorization of root cause and a little bit of vehicle recall. I'm trying to piece together all the highlights for my research. Let me begin by showing you the graphics of the human-machine environmental system. This was proposed by Japanese, one of the great scholars in human factors. You can see the upper part is human, and then the bottom part is the machine. And the interesting thing is that there is always a sensor part, a processor part, and an actual part. This is the typical for any kind of functional block diagram. Okay, so and then outside is the environment. It's how we try to analyze accident or analyze any kind of system in terms of man-machine environment task. In summary, I would like you to remember that for human factor system thinking approach, first, you kind of have to identify the problem and try to draw a system diagram and then try to come up with some kind of mental model. In the end, you have to identify the leverage point. And what I mean by leverage point is to find the root cause. The reason why I brought this up is because what I'm going to talk about today is about accident analysis. And for accident analysis, the key point is to find the root cause. And if you find the root cause, you will be able to find the leverage point, you will be able to solve the problem. That's why I have to bring this up. And let me go back to a little bit about what I have learned for my PhD study. I was in State University of New York at Buffalo between 1985 and 1990 with Dr. Karen Jury. This is my academic father. And one of the courses he teaches is human factors in safety. And he had published this paper called Human Factors in Consumer Product Accident Investigation, which I like the most. One thing that hit me is that we try to describe accident in terms of scenario. Actor is man, and then prop is the machine. And thing is the environment, so it's still man-machine environment, and the action is actually a task. Another thing he told me was the importance of visualization. How can you use graphics to express the accident scenario and accident patterns? And let me just show you a little bit about where I get started. Where I get started was trying to look at the occupational accident report in Taiwan. It's a lot of Chinese characters. And it's so easy for the upper part because for the type of industry, for the age, for the gender, and source of injury. There is always very easy to find classification for that. But the difficult part is that how the accident happened and why it happened and how we can stop it from reoccurring. Nobody really taught me how to do it. I started trying to think about how about if I try to classify or create some kind of categorization system for the root cause. It could be great. I started trying to explain the importance of my work, and then I find the importance of categorization. One of my sisters invited me to stay over for the Chinese New Year, and I don't know how to play mahjong. The game was based on categorization and sorting. Would explain better about the importance of categorization. Categorization gives us a way to describe an item to others. It allows us to describe things in a meaningful way. And because it becomes meaningful, we can remember better. By doing categorization, it allows us to be able to remember more things. After that, I was trying to categorize root cause for fall, electrocution, cut in between, and escalator riding accident. What I've been trying to do, I follow the idea of man-machine environment. It's always start by unset behavior, unset machine and tools, and then unset environment. And at times we do look into the unset task factors. And this is one of the examples that we do for root cause analysis of fall. Again, we try to look at the unset behavior. Here is the easy part because it's always the same, unset behavior, unset machine and tools. This part is more difficult. How can you create homogeneous but then mutual exclusive categorization for root cause? And you have to imagine, now it's there so that it becomes obvious and straightforward. You have to imagine this is empty, and then you have to create a list. Okay, and that's the unset environment. So we have to review a lot of papers and then try to fit into the case and try to find the right wordings for each of them. I've been doing that for different kind of accident, but at the time, I was also doing the ICOM study. It's a very interesting emergent that you combine the ICOM with fault tree and then come to a new idea called graphical fault tree. The idea was that fault tree is very boring, and if you try to add graphics to it, it becomes interesting and then better for communication. I was trying to think about, hey, how can I try to apply root cause analysis into something else? Because at the time, root cause analysis was not so popular like now. Nowadays, you apply root cause analysis in hospital, in everywhere. But then at the time, root cause analysis only for accident. Until one day, I heard something from the news about one guy, he was driving the Lexus and tried to call 911. And it was very scary because there is no brake. And actually, there are 4 people inside the car, crashed and died. Okay, because no brake? No, because his gas pedal gets stuck. Okay, gets stuck. That inspired me. Hey, I can do something about it. I can apply root cause analysis to this vehicle recall case. So actually, I think I spent kind of 10 years. Why? Because you need some chemical engineering background to do it, because this is more focused on the machine value, not human. In order to bring other people's attention to human factors, sometimes you have to understand their language so that you can communicate better. I try to look into the defective component and then cause of recall. Now you look at it, you will say, this is simple and straightforward. But at the time, there was no category at all. Now, after we generate it, it becomes so simple and straightforward. I need to apply something that is so typical for mechanical engineering, the functional block diagram and the failure mode effect analysis. I try to apply something that I did for the vehicle recall. I spent 10 years for doing that. And why don't I spend more time doing the aviation? People understand about abstracts. And everybody apply abstracts to medical field, to aviation field. There are some other models, such as the ones proposed by Australian Transportation Safety Board. And then there is one more that is just published recently, that is by IATA, International Air Transport Association. I was trying to code the 3 different models, okay? And it was not very successful trying to code the accident in Taiwan. In the end, I come up with my new model that is called HMEP, based on human, machine, environment, and procedure. Like I said earlier, the first layer is the easy part. What's difficult is the bottom part here. I have to incorporate all the three models before and then try to create something new. We have tried to apply the model on helicopter, and right now we are trying very hard to fit in to the airplane accident.
We are pleased to share that after years of hard work, we have extended our HMEP model to the root cause analysis of airplane technical failures and published in Applied Ergonomics.